Hey and welcome, Pure Maths 3 students. Hopefully you've had a chance to do the week 2 of the maintenance on your own. I fully suggest that you do have a go at it yourself before you watch this video. I think you learn more that way rather than just watching me do them for you. So I think it's best practice for you to spend some time during the week practicing, having a go, and any questions that you have, then you can pay closer attention to the ones that you were stuck with when the video comes out. Alright, let's get into it. So the method that I've been using for these has been squaring both sides. So I will continue doing that in this video. Alright, so we're going to square both these. So I get 9x squared minus 12x plus 4 is equal to 16 minus 8x plus x squared. I think I'll pull everything across to the left hand side, so I get 8x squared minus 4x minus 12 is equal to 0. I think that's right. Okay, now I'm going to divide everything by 4, so I should get 2x squared minus x minus 3 equals to 0. And then I think I can factorize this. So I want to times that by, I'll have my minus 3 here and my plus 1 here. I think that's it. So we should get x is equal to 3 over 2 or minus 1. Okay. Now for the next one we've got an inequality. So we're looking at where is this less than 7. So what we want to first of all do is consider where it's equal to 7. Okay, so that's what we'll do first. I'm going to go and square both sides. I'm going to make it equal to 49. So we're just going to find where it's equal. 4x squared minus 6x minus 12x plus 9 is equal to 49. Now we go 4x squared minus 12x, pull that 49 across, we get negative 40 is equal to 0. Divide everything by 4, so I get x squared minus 3x minus 10 equals to 0. And then x minus 5, x plus 2 equals 0. So we know that our roots for the equation, or where the modulus function meets, where it's equal to 7 is at 5 and negative 2. So now what I might do is do a quick sketch. So where am I going to do that? Okay. So when you're sketching a modulus, let's say we had something like this. You know in that situation that the 0 point is at minus 3, because minus 3 plus 3 is 0, and then everything else is going to go like this. Okay, so that's kind of how they go. Now this one is a little bit different because we've got that 2x. So the crossing point where it meets the x-axis is at 3 over 2, or 1.5. Right, and then it goes up like this, and then it goes up like this. Okay. Now, what we've just found here is that x, where it is equal to 7, is at 5. So 5 might be, say, let's say it's over here. That's 5. And also negative 2. And we want to know where it is less than 7. And you can quite easily see, well, where it's going to be less than 7 is from here to here. So our final answer should be minus 2 is less than x is less than 5. And that should be all we need for that one. So it's good to be able to just quickly sketch these as well. Okay, now the next one, we've got given that fx is equal to x cubed plus 2x squared minus 9x minus 18. Use a factor theorem to help you find factors of fx and fully factorize. So what you want to do here, sometimes you've got a calculator that can do this, but you want to plug in some numbers. So we might try f1, right? And you go, all right, 1 cubed, 1. 2 times 1 squared, 2. Minus 9 times 1, so that's negative 7. Negative 18, so I think it's negative 25. Okay, and you go and do this for a few values. I generally tend to go from minus 5 to 5, but if you've got a calculator like the one of the Casio standard ones that we use at school, it should be fine. So you should be able to go to, I think it's table mode. So click on the mode button, and it I think it's 3 or 7 depending on the model calculator you have, has table mode. You put in the function, so in this case it's going to be x cubed plus 2x squared minus 9x minus 18. And when you've typed in the function, you go equals, and then it'll go start question mark. And what you want to do at this point is put in the lowest value you want to check for. So I'm going to go minus 5, and then it asks end question mark, and then maybe go up to 5, say. And then it will say step, and you want to go up in steps of 1 at a time, so you're just hitting up all of the integers. So, and then it will spit out a table for you. And what you want to look for is where the x value that you put in gives you an fx value of 0, because that means it's a root. Okay, so what roots have I got here? I've got roots at minus 3, minus 2, and 3. So that's all of the roots for this equation because it's a cubed. So when you want to factorize, you take your roots, like let's take this one here, and if minus 3 is a root, that means minus 3, x minus 3 is a factor, right? Or x plus 3. And you kind of know this. I'll show you in a second why. And then the next factor is x plus 2 for that one. And then this one is x minus 3. Okay? And you know this, right? Why do you know it? Because when you are trying to find solutions to an equation that's factorized, you know this solution here is that one there. And this solution here, well, you'd need a minus 2. And this solution here, you'd need a positive 3. Okay, so we've fully factorized that equation now. Now we've got to solve the equation. Well, we already did that. Fx equals 0. Where does it equal 0? At the roots. When x is equal to minus 3, minus 2, or 3. And then we can sketch the curve. Okay, if you've got your table mode and you've done that, you'll see the rough design, or the rough look of the curve. So here's y, here's x. This is not to scale, it's a sketch. Okay, we've got a root at minus 3. So here's minus 3. We've got another one at 2. Here's minus 2. And then we've got another one at 3. So over here somewhere. Okay, now, if you've got your table mode, you just look at where you started. So we started at negative 48, and we're coming up until we get to here. So it's down. And then we go above, well, we go from 0 to 0. So it must be going like this. And then it goes down. And then comes back up again. Like that. And that's our sketch. It's a pretty crude sketch, but it'll do the trick. Okay, the other thing you might want to find is this point here, which is pretty easy. That's actually at minus 18, and you can see why by looking at this. Okay, if when you're crossing the y-axis, x is 0, so it must intersect at minus 18. So we could probably just pop that down there as well as minus 18. Okie dokie. That is our algebra work. Now we're moving on to logarithmic and exponential functions. Let's take a look at the rules, the log rules first. So I'm going to rewrite this as log 5 plus log 2 cubed minus log 10. My next line, I could write it log 5 plus log 2 cubed is 8 minus log 10. And that's log 5 times 8 is 40 minus log 10. And final answer, log 40 over 10, which is 4, log 4. Okay, so this one here, I'm going to write as half log 4 plus log 1/2 squared, which another way of writing that is, of course, 1/4. And next line, log 4 to the power of 1/2 plus log 1/4. Now, 4 to the power of 1/2 is like the square root of 4, which is 2. And now we're going to multiply those together using our log rule. So it's 2 over 4 or log 1/2, because it was 4 there, wasn't it? Okay. Right, next one. Next line for C, I would go log 16 minus log 2 cubed, which is log 8. And then it's plus log, now 3 squared, which is log 9. At this point, I would go log 16 minus log no, what I would do here is I would go log 16 over 8, which is log 16 over 8 is 2. And then equals log 18. And the next one, I would rewrite this as log 4 squared, which is log 16, plus log 9 minus log, now 144 to the power of 1/2, okay, which another way of writing it is square root 144, and another way of writing that is log 12. Okay, now log 16, now how could we do this? I think 16 times 9 is probably what we want here, so what's that? 16 times 9 is 144, log 144 minus log 12, and then that's the same as log 144 over 12, which is obviously equal to log 12. Okay, so moving on, for this next one here, we're expressing in terms of log x. Okay, well, that's basically 2 log x, okay, using our log rule. So that squared can go in front there. This next one, I could write it as 5 log x, using the same thing, right, 5 log x, minus 2 log x, and we can simplify that to 3 log x. Okay, brilliant. Now, the next one, solve the equation ln 2x plus 3 equals 2 ln x plus ln 3. Now remember, what we're trying to do is get rid of the ln's. The first step is to get it in terms of ln blah equals ln blah. Okay, you just want one ln on each side. That's how you solve these. So what we're going to do is, the first one's perfect. I'm happy with that. The next one, I'm going to write it as ln x squared plus ln 3, and then I'm going to use my log rule in the next line to make it ln 3x squared. Now we can get rid of the ln's because it's ln blur equals ln blur. So we get 2x plus 3 equals 3x squared. Now I'm going to pull everything across to that right hand side and I'll get 3x squared minus 2x minus 3. And what can we do here? Can we factorize that? 3. Yeah, I think so. So let's go 3x bracket 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 x, we want minus 1 plus, no, what am I thinking? What a Larry. Okay, no. So this is not going to work. What I'll do at this point is I'm going to use my quadratic formula. So I'm going to pop this into the calculator. Whoops. 3 minus 2 is B and minus 3 is C. Spit out our answers. I'm getting x equals 1.39 or x equals 0.721. So those are our answers to 3 significant figures. Now, what I would do is save those answers, and I'm just going to do a quick check to see that they work. So let's use the first one. So we can go ln 2 times 1.39 plus 3, and then that's 1.75. Okay, and then we'll do 2 times ln 1.39 plus ln 3, and that's 1.75 or 1.76. So yep, there's maybe small rounding errors there, but yep, that's perfect. We're done. Okay, team. Well, I hope that helps. I hope it makes sense. Give me comments if you've got questions, or chat to me on ThinkWave. Let me know how you're going with these. Happy to help and give further assistance as necessary. All right, team. God bless. See ya.